Hare Krishna everyone. Today we will start with a call. Okay. In previous classes I have discussed about gradient and your divergence. So today we will see what does call mean by. Okay. So let's start with today's session. Okay. Okay. Hope you all are doing well in your exam. Okay. So what do we mean by call? Let me first write it. Call. You all have known that gradient acts on a scalar and divergence acts on a vector. Similarly, call acts on a vector. Okay, it acts on a vector. Okay, call acts on a vector and gives the product you get is the vector. Okay, so how do we represent call? We generally, if I have a vector as your ax I cap, ay j cap, az k cap, I will represent it the call of a vector, that is grad, that is your del cross a is equal to your I cap, j cap, k cap, and your here it is del by del x, del by del y, del by del z, and your components along with I cap, that is ax, along with j cap, that is ay, and along with k cap, that is az. Okay, this one is call of a vector. Okay, you know how to expand it, you can write it. Okay, so we do the geometrical interpretation. We do the geometrical. Let me minimize it further. Please student, hold a minute. Yes, good to go. The geometrical interpretation, when I am saying the geometrical interpretation of call, remember, call means if it tells you about the rotation or twist of a vector, it tells you about the rotation or twist of a vector. Okay, remember, it tells you how much a vector is rotated or how much a vector is twisted. Okay, so when call of a vector, let's suppose call of a is 0, it means it is the a vector is irrotational. Okay, if call of a vector field is 0, you are getting the call of a vector field is 0, then you can say the vector field is irrotational. Okay, so this is all about your call. Now we will see expression for call in different coordinate systems. Okay, so first see the spherical coordinate system. The spherical in spherical we have call of a, we represent it as 1 upon r square sine theta, determinant of r cap, r theta cap, and your third is r sine theta phi cap. As you know, in spherical we have the components as r theta phi. Okay, so I am writing del upon del r. You can also say it dou upon dou r, dou upon dou theta, dou upon dou phi. Okay, and the components ar, and here you have with a theta you have r a theta, and with a phi you have r sine theta a phi, isn't it? Yes. Similarly for cylindrical, we will see for cylindrical, in case of cylindrical you have rho phi z. Okay, so I will write call of a vector as your 1 upon rho. In determinant you have rho cap, rho phi cap, and z cap. Similarly, dou upon dou rho, dou upon dou phi, and dou upon dou z. In determinant you have a rho and rho a phi and a z. This was the expression for spherical and cylindrical coordinate system for call. Okay, so let me tell about something important, that is your vector identities. Yes, You need to know about these vector identities in order to solve problems. Okay, let me write fast. Okay, so first one, you have grad of phi a vector. Here phi is a scalar, so how can you write it? Phi divergence of f plus grad phi dot f vector. Okay, you can write it like this. Second, we have call of phi a vector, so you can write it phi call of f plus grad phi cross f vector. Okay, you can write it like this. And third, I have divergence of a cross b, so it will become your b dotted with call of a minus similarly now a dotted with call of b. Okay, see, these three are the product roots. These three are the product roots. It is easy to remember, you just have to memorize it. Okay, in order to solve problems, various problems we will discuss in the class. Okay, in order to solve the problems, you need to know about this. Okay. Fourth one, you have call of grad phi is 0. Remember this one. Call of grad phi is 0. And the third one, I have divergence of call of f is equal to 0. Okay, and I will talk about the Laplacian. What does it mean by Laplacian? You can write it as divergence of grad phi, and we write it like grad square phi. This one is the Laplacian. This one is known as Laplacian of a scalar. Okay, so what does it mean? It means grad square means your del square, del x square, del square, del y square. It will operate on a scalar field. Okay, so grad square, del square, del z square. Okay, so this one is known as Laplacian operator. Okay, hope you all are clear up to this. Next, I have some problems for you. I will recommend you to solve the exercises of H.K. Das. Okay, you know this book is a very famous author, H.K. Das. You need to solve the exercise. Okay, in order to solve this, I have done all the formulas required for this. These are the vector identities you will be needing in order to solve the problems. Okay, so solve the questions. I will discuss about the problems, all the difficult problems in the next class. Okay, I hope you all can do and comment in the video which problems you are facing problem with. I will discuss in the next class. Okay, so thank you very much watching this video. Do like, share and subscribe.